Hello, today we are going to be talking about solving inequalities. This is part one of a two-part series. Today we will do a brief overview of what an inequality is and then look at how to solve them. So remember that an inequality is a that has two or more quantities or expressions that are not equal, thus the name inequality. For example, you can have x is less than 2. Which means x is any value that is less than 2. So -1, 1, 0, -50, -0.5, 0.5, etc. If we draw this on a number line to represent the statement, we have in this example, you may see it possibly written with a parentheses or bracket, closed circle, open circle. These two are the same, and these two are the same. It just depends on your preference. If we look at another example, x is less than or equal to 2, then we would, looking at this on a number line, we have this closed circle, and this just means that this value goes up to 2, where in this example, the value goes close to 2, but doesn't actually get to 2. Other examples of inequality, we can switch this around. We can have x is greater than or equal to 2, or x is greater than 2, which would just inverse these graphs. Another inequality statement we can see is 2 is less than x, which is less than 5. This simply states that the value of x is between 2 and 5, but with the limits that are not equal to 2 and not equal to 5. We see this value of 2, we see this value of 5. This means that it cannot, this less than sign means that it cannot touch 2, and so therefore we have an open circle, and this value cannot touch 5, again because we have an open circle, which means we can go up to or near 5, but we can't actually go to 5, and then it's every value that's in between 2 and 5. So that's what that looks like on a number line. If you wanted to use parentheses, it would be the exact same thing. It would just be 2 and 5, and you would have an open parenthesis and an open parenthesis with numbers there. If these were equal to, similar to what we have in the second example, it would just be a bracket instead of a closed circle. They all mean the same thing, it's just what you choose to use. Now that we have reviewed what inequalities are, let's look at a very important rule when solving inequalities. Okay, looking at rules of inequality, I do not know if this is the technical name for it, but I call it the reversal rule. And this simply states, even though this might not be the technical name for this rule, you'll understand why here in a second. I call it that. When solving for x and you are multiplying and or dividing by a negative number, it's important to remember that you need to reverse the inequality. If you have negative x, which is less than 1, to solve for x, you would just need to divide each side by -1, and this becomes x, which is greater than -1. Because we divide it by -1 on both sides, we need to flip this inequality sign. It went from -x, which is less than 1, to x is greater than -1. Similarly, if you wanted to multiply, say you had -2x, which is greater than or equal to 2, and we multiply each side by a negative value, that's going to give us 2x, which is less than or equal to 2. Solving for x, we divide each side by 2, and that would leave us x, which is less than or equal to 1. Note that this only applies when multiplying and dividing with a negative number, not adding and subtracting. Outside of the reversal rule, you can almost treat the inequality as an equal sign and solve the equation. And that is exactly what I did here. I just treated this as an equal sign and went through the problem. But let's look at a few more examples so we can get a good grasp on this concept. Okay, looking at our first example, we have negative 4x plus 5, which is less than 37. Again, when dealing with inequalities, we can treat it essentially as an equal sign unless we are multiplying or dividing by a negative. With that, we are going to get the x on one side, so we're going to subtract 5 from both sides. That leaves us negative 4x, which is less than 37 minus 5 is 32. Okay, now what we need to do is get the x by itself, so we can divide both sides by negative 4. And because we're dividing by this negative, we need to ensure that we flip the inequality sign. This becomes greater than, and then we do negative 4x divided by 4, which gives us x, 32 divided by negative 4, which is negative 8. And this is our answer. This inequality is accurate when x is greater than negative 8. Let's try 0. Negative 4 times 0. 0 is greater than negative 8, plus 5, we'll say, is less than 37. So we have negative 4 times 0, which is 0, plus 5. We have 5, which is less than 37. And that is a true statement. Let's try another one. Let's do negative 7. See if that works. Negative 4 times negative 7 plus 5. Negative 4 multiplied by negative 7 plus 5, which is less than 37. 28 plus 5, which is 33, which is less than 37. That checks out as well. Let's try a number that's less than negative 8 and see if that works. If we try negative 10, we have negative 4 multiplied by negative 10 plus 5, which is less than 37. If we have negative 4 times negative 10, that's going to give us 40 plus 5, which is less than 37. 40 plus 5 is 45, which is less than 37. This is not a true statement, and therefore we know that this is the correct answer. Let's look at another example. For this example, we have 0, which is less than or equal to 4, minus 1/3 x, which is less than 2. When working with two inequalities, all you have to do is set up two sets of equation. And the reason for that is so that you satisfy both sides of the argument. Therefore, you're going to set up an equation that contains this. So 0 is less than or equal to 4 minus 1/3 x. And then you're going to set up a second equation that's going to pertain to your other side of your inequality, which is 4 minus 1/3 x, which is less than 2. When you solve for both of these inequalities, you will get two answers that will satisfy each of these inequalities. Looking at the first equation that we're going to set up, 0, which is less than or equal to 4 minus 1/3 x. And then the second inequality that we're going to set up is 4 minus 1/3 x, which is less than 2. Looking at this first inequality here, we're going to get 0, which is less than or equal to 4, minus 1/3 x. We move the 4 over to the other side, and because we're not dividing or multiplying by a negative, then we don't have to worry about flipping the sign. So we subtract 4 from both sides. We get negative 4, which is less than or equal to a negative 1/3 x. Now what we need to do is multiply each side by a negative 3. Because we're multiplying both sides by a negative, we need to take care of this inequality by reversing it. If we multiply both sides by negative 3, then we get negative 3 times negative 4, which is 12. We're flipping the inequality sign, so now that's greater than or equal to x. And that is our first answer. Now what we need to do is look at our second inequality. So we're going to rewrite that. We get 4 minus 1/3 x, which is less than 2. We move the 4 over to the one side. We get negative 1/3 x, which is less than negative 2. And then we need to multiply each side by negative 3 to get x by itself. We get x, and because it's negative, we need to flip the inequality. Negative 2 times negative 3 is 6. Our answer is 12 is greater than or equal to x, and x is greater than 6. If we wanted to look at this on a number line, we would have 0, 6, 12. We have 12, which is greater than or equal to x, so that means x is less than 12, and we're going to go this way with it. However, x is greater than 6, but it's not equal, so we have an open circle, and it's going to go this way. So now it's any value that's between 6 and 12. If we wanted to check our answer in the original inequality, let's choose a number 9, because 9 does fall between 6 and 12. We can see that 0, which is less than or equal to, we have 4 minus 1/3, and again we're going to choose 9, which is less than 2. If we simplify this down, we get 0, which is less than or equal to 4 minus 3, less than 2. This is going to go 0, which is less than or equal to 1, which is less than 2. And this checks out because 1 is greater than 0 and it's less than 2. Let's look at one more example. Okay, looking at our final example, we have 2 divided by the quantity x squared minus 2x plus 1, and that's greater than 0. Looking at this problem, we know that this value has to be greater than 0. And since the numerator is positive with 2, this means the fraction is positive if and only if the denominator is greater than 0, which means it makes it a positive. If the denominator was less than 0, then we would have a positive divided by a negative, which would give us a negative. We need to be positive to satisfy this argument, and therefore we know that the denominator has to be greater than 0. And so now that we know that the denominator has to be greater than 0, all we need to do is solve the denominator to ensure that we have a value that is greater than 0. And if that's the case, then we would just need to rewrite this as x squared minus 2x plus 1, which is greater than 0. In this case, there are a couple ways to solve a quadratic equation. You could use the quadratic formula, you could use factoring, you could use the sum of squares. All of those I will link in the description below if you need a refresher. In this case, I'm going to use factoring because it's a pretty simple problem. With factoring, we get x minus 1, which is greater than 0. From this case, we see that we're going to have a multiplicity of 2. It's going to be x minus 1, which is greater than 0. So x is greater than 1. And that's going to be our answer. So any value of x that is greater than 1 is going to solve this inequality. If we wanted to show this on a number graph, all we would need to do is 0, 1, and we have any number that is greater than 1, that's not 1, but greater than 1, is going to satisfy this problem. Let's check our work. Any number greater than 1, let's try 2. If we try 2, we're going to get 2 divided by 2 squared, which is 4, minus 2 times 2, which is 4, plus 1. This simplifies to 2 over 1, which is equal to 2, and that is greater than 0. That checks out. If you want to check another problem, you can do, let's try 10. So we get 2 over 10 times 10, 100. 100 minus 20 plus 1. We get 2 over 100 minus 20, which is 80, plus 1. which is 81. 2 divided by 81 is greater than 0, and this also checks out. And there you go. If you have any questions, please leave them in the comments below. If you learned something, please like and subscribe, and we'll see you next time.